Welcome back to second session of this experimental part. In first session, I have discussed about the practical, that is the verification of Ostwald dilution law and determination of the dissociation constant. In the first section, I have discussed what is actually Ostwald dilution law and what are the different objectives. Say for example, the first part of any conductometric experiment is that determination of the cell constant, preparation of different acetic acid solution, preparation of n by 50 kCl and n by 100 kCl, and you have prepared all the solutions. Now this is the second part. Here what? Now you will perform the experiment and you will give me the results, and on the basis of your results, that means the observed conductance of different acetic acid solution, we will verify the Ostwald dilution law and we will determine the acetic dissociation constant of acetic acid. Let us go to the laboratory. Please go. Hello student, I welcome you in this physical chemistry practical session. Today I am demonstrating a very important and simple experiment, and the objective of this experiment is determination of equivalent conductance of different acetic acid solution. And what is the purpose of this experiment? To verify most important Ostwald dilution law. You all are aware of the various theories of observed conductance, specific conductance, as well as the equivalent conductance. Here we will determine the dissociation constant of acetic acid, and this value is approximately at room temperature 1.8 into 10 to the power minus 5. For this simple experiment, today I have allotted 3 students. What is the name of you? Just tell your name.
Myself.
Very good. These 3 students have prepared all the solutions. Okay. There are 2 objectives, because here we are using a conductivity bridge, or sometimes it is known as conductometer. Why? Because with this instrument we will measure or determine the observed conductance of these solutions. You see, there is a cell that is called conductivity cell. What is it? It is conductivity cell. And you know the theory of the cell constant. Sometimes there are 2 electrodes and the distance may not be always 1 centimeter, and area of cross section is 1 square centimeter. So first part is that. What is the first part of this experiment, Sahu?
Firstly, we prepare n by 15 and n by 100 kCl solution. Then we उसको मेजर करेंगे. उसके बाद उसका कंडक्टिविटी मेजर करने के बाद उसको सेल कंडक्टेंस निकालेंगे.
सही बोल रही हैं. पहला एक्सपेरिमेंट शुरू करने से पहले सबसे पहले हमको सेल कांस्टेंट निकालना है. सेल कांस्टेंट, क्योंकि द आइडियल वैल्यू ऑफ द सेल कांस्टेंट, द डिस्टेंस बिटवीन दैट two electrode is maybe 1 centimeter. May not be some changes. So we have to determine the cell constant, the first part. And second part, we will prepare, you have already prepared different acetic acid solution, maybe 1 molar, 0.1 molar, 0.01, 0.001, 0.005, like that. Now to determine the cell constant, they have prepared two solutions. One is N by 50 potassium chloride and second is N by 100 potassium chloride, and determine the observed conductance. Because you know that the formula of specific conductance is observed conductance multiplied by the cell constant. Suppose your cell constant is 1, so the values of observed conductance and specific conductance will be same. And in B.Sc classes you are all aware of, there is very popular question, what is the effect of dilution? If you dilute the solution, whether specific conductance decreases or what about the equivalent conductance? So there are two parts. One part is the cell constant determination. She has prepared the solution and measure the observed conductance, and you have seen that this is N by 100 KCl solution, and what is the value of 1.38 millisiemens, because the unit of earlier, yes, earlier it was moles and micromoles, now generally in SI unit it is Siemens. Okay. Now what are the most important precaution? When you perform the, जब आप conductivity का experiment करते हैं, because we are dealing with the conductance of the ions, conductance of the potassium ion, conductance of the chloride ion, conductance of the hydrogen ion. So our water must be triple distilled water. Why? Because the ideal condition is that the observed conductance of triple distilled water must be less than 1 microsiemens. Today you have collected the double distilled water from research scholar lab. I am not very happy because you are getting around 4.5 microsiemens, but it should be कितना होना चाहिए? 1 microsiemens से कम होना चाहिए. Okay, and then that girl measured the observed conductance, and the formula of cell constant is very simple. I think she has taken the values of specific conductance. Today what is the room temperature? आज कितना room temperature है? कितना? Maybe 31, maybe, but ideal condition is 25 degrees centigrade or like that. So what she did, the formula is that specific conductance divided by the observed conductance, and I am very happy that her result is approximately 1.09 is the cell constant. There is no unit of cell constant. This is the cell constant. It must be approximately 1. And then in N by 50 maybe 0.89 or 0.90. So what she will do, आप लोग क्या करेंगे, दोनों का एवरेज निकालेंगे तो वो आपके सेल कांस्टेंट आ जाएगा. क्यों सेल कांस्टेंट की जरूरत है? Because when you see the formula of Ostwald dilution law, alpha square 1 minus alpha CV, so first part is that you determine the cell constant. सबको समझ में आया? एक बार इनको दिखाइए, क्योंकि आपको नेक्स्ट टाइम इसको करना है. तो सेल कांस्टेंट 1 आना चाहिए था, ठीक है, नहीं आया 1, लेकिन इन दोनों को एवरेज से करेंगे तो 0.9. नाउ व्हाट दे विल डू, दे विल डिटरमाइन दी observed conductance of acetic acid starting from, they have prepared different solution. क्या क्या solution बनाए आप बताइए? By dilution method से, dilution method से
0.01, 0.001 and then 0.001 and then 0.001.
Okay, so she will measure, they will measure the observed conductance and then they have to multiply with this cell constant, which you determine through your system. So you will get the specific conductance. तो आपको समझ में आ जाएगा. Then you will write the results. First is 1.1 point like that. Suppose you have prepared like that. 001, 01 maybe, or 0.005 any type of solution, and measure their observed conductance. First is observed conductance multiplied by the cell constant. You will get the specific conductance. Then from specific conductance, you have to determine the equivalent conductance. Tomorrow I will ask you the question that what is the effect of dilution, and then from equivalent conductance you have to determine the K, that is dissociation constant. If you have अगर आपका एक्सपेरिमेंट बहुत अच्छे से हुआ तो आपको क्या रिजल्ट आना चाहिए? सारे जितने भी एसिटिक एसिड सोल्यूशन है आप लोग को खुशी होगी कि नहीं अगर आपका रिजल्ट सही आया? आई एम नॉट श्योर बिकॉज यू हैव प्रिपेयर्ड दिस सोल्यूशन. तो पहला पार्ट फिर से मैं रिपीट कर रहा हूँ. पहला पार्ट में हम लोगों ने सेल कांस्टेंट निकाला एंड आई एम हैप्पी विद द रिजल्ट्स, बट आई एम नॉट हैप्पी विद द रिजल्ट्स ऑफ द वाटर. दूसरा पार्ट में आपको 10 मिनट भी नहीं लगेगा, आपने इस सोल्यूशन का सबका ऑब्जर्व कंडक्टेंस निकालेंगे और घर में जाके उसका कैलकुलेशन करेंगे. फिर आपको मैं ये दिखाना चाहता हूँ, मैंने आपको शायद थ्योरी क्लास में बताया, देयर इज़ ए वेरी गुड बुक. द नेम ऑफ द बुक इज द इलेक्ट्रोकेमिस्ट्री बाय सैमुअल ग्लास्टन. हो सकता है आज से 50 साल पहले उस किताब को लिखा गया. इलेक्ट्रोकेमिस्ट्री बाय एसेंशियल ऑफ इलेक्ट्रोकेमिस्ट्री बाय सैमुअल ग्लास्टन. टुमारो आई विल ब्रिंग दैट बुक, and that book they have given the values of equivalent conductance and observed conductance of acetic acid solution. अगर आपने बहुत अच्छे तरीके से एक्सपेरिमेंट को किया तो आपके जो ऑब्जर्व कंडक्टेंस की वैल्यू है उस बुक्स के ग्लास्टन के साथ बिल्कुल टैली हो जाएगा. और तब जाके फिर हम ओस्वाल्ड डाइल्यूशन लॉ क्या है उसको हम लोग आपको समझाएंगे थ्योरी क्लास में, एंड व्हाट इज़ द ओस्वाल्ड डाइल्यूशन लॉ. एंड और इसका ऑब्जेक्टिव दूसरा भी हो सकता है कि डिटर्मिनेशन ऑफ डिसोसिएशन कांस्टेंट ऑफ एसिटिक एसिड, बिकॉज एसिटिक एसिड इज डिसोसिएट. दैट मीन्स इफ आई राइट लाइक दैट CH3CO, so K is equal to this CH3COH. This value is 1.8. All the values should be 1.8 into 10 to the power minus 5. And don't throw any solution. जब next batch आज ये 3 लोगों ने किया, कल फिर दूसरे लोग करेंगे, तो उसमें हम लोग आपको ट्रेनिंग देते हैं कि एक्सपेरिमेंट को पहले घर से पढ़ के आइए, डिस्कस विथ अस, डिस्कस विथ अभिषेक कतेंद्र यानी योर क्लास टीचर, देन यू परफॉर्म द एक्सपेरिमेंट. तो आप देखेंगे सारे एक्सपेरिमेंट का रिजल्ट एकदम सही आपको आएगा. तो आज हमने इसको किया, कल जब इन्होंने रिजल्ट को लेके आएंगे मेरे पास, अभी आप 1-2 का रिकॉर्डिंग कर लीजिएगा, उसके बाद आप कैलकुलेशन करेंगे. आपको अगर कैलकुलेशन नहीं समझ में आएगा तो हम लोग आपको कैलकुलेशन करेंगे. तो सेकेंड पार्ट ऑफ दिस वीडियो लेक्चर विल बी दी कैलकुलेशन. तो इस तरह से हर एक्सपेरिमेंट को अगर हम इस तरह से करेंगे, जैसा कल हम आपको करेंगे pK ऑफ बेंजोइक एसिड, और सारे इंस्ट्रूमेंट व्हेनेवर यू फेस एनी प्रॉब्लम यू कैन डायरेक्टली कम टू मी और डॉक्टर भुवनेश्वरी साहू और डॉक्टर अभिषेक कतेंद्र और एनीबडी. अभी आपने सारे उसी तरह से पोटेंशियोमीटर है, उसी तरह से केमिकल काइनेटिक्स है, फ्लेम फोटोमीटर्स है, देयर आर सो मेनी कलरीमीटर टाइप ऑफ द एक्सपेरिमेंट है. बट माई सजेशन इज दैट बिफोर परफॉर्मिंग एनी एक्सपेरिमेंट you must read the experiment thoroughly, and there are some instruction. I will request Dr. Abhishek Katendra, please take that the laboratory precaution and other things. That is very important. You must wear, yes, and proper apron must be there, and hand gloves कहाँ है आपके पास? हाँ, ये दिखाइए. Solution वो तीनों बफर सोल्यूशन दिखाइए मेरे को जो प्रॉपरली लेवल्ड है. बफर सोल्यूशन यहाँ रखा हुआ था ना, लाइए जस्ट शो में. वो देखिए बफर सोल्यूशन कैसे आपको सोल्यूशन को प्रिपेयर करना है, हाउ डू यूज़ दी. यस एंड शो मी दी बॉटल ऑफ KCl. यू सी टुमारो विल परफॉर्म दी pH मीटर, pK ऑफ बेंजोइक. आपने देखिए किस तरह से बच्चे स्टूडेंट ने सोल्यूशन को बनाया. यू मस्ट राइट 0.0 m बोरेक्स, 0.05 पोटेशियम हाइड्रोजन थैलेट, एंड यू मस्ट मेंशन द डेट ऑल्सो. ठीक है, दिख रहा है, अच्छा दिख रहा है कि नहीं दिख रहा है? अब KCl का दिखाइए, KCl का जिससे आप लोग बनाए हैं वो केमिकल्स लाइए. देयर आर डिफरेंट टाइप्स ऑफ केमिकल्स. ग्रेट, ब्रिंग द KCl. KCl कहाँ से लिया आप? वहाँ पर रखा होगा KCl. What I mean to say, you must know the grade, make of that chemicals. अगर there are many types of grade, one is called the AR, analytical reagent grade. You must know because you are now chemist, and some are very toxic chemicals. हाँ, ये अच्छा आपने नहीं लाया बॉटल. अच्छा बॉटल लाना चाहिए था आपको, नया बॉटल लाना चाहिए. एनीवे, इसको डिलीट कर ये. तो ठीक है, थैंक यू वेरी मच. अब कल हम इसका सेकंड पार्ट करेंगे जब हम आपको पूरे बोर्ड में कैलकुलेशन करेंगे. और अगर एक ग्रुप ने बहुत अच्छे से एक्सपेरिमेंट कर लिया तो इट विल बी हेल्पफुल फॉर अदर्स ऑल्सो. दी ऑनेस्टी इज़ द बेस्ट पॉलिसी. फिजिकल केमिस्ट्री एक्सपेरिमेंट में जितना आप लर्न करेंगे, जितना आप अच्छे से करेंगे, इट इज़ यूनिवर्सिटी टीचिंग डिपार्टमेंट. आई एम रियली ग्रेटफुल टू यू दैट यू आर परफॉर्मिंग द एक्सपेरिमेंट विद द ऑनेस्टी. बट मैं बार बार आपको बोल रहा हूँ, प्लीज़ before performing any experiment, read it properly and prepare the solution very carefully. properly label करिए. एप्रॉन आपके पास होना चाहिए, ग्लव्स होना चाहिए, फिर आपके पास वो ग्लास भी होना चाहिए, चश्मा भी होना चाहिए ताकि कोई केमिकल्स आपके यहाँ पे ना जाए. प्रिकॉशन, लैब सेफ्टी इज़ वेरी इंपॉर्टेंट. लैब सेफ्टी इज़ वेरी इंपॉर्टेंट. अब बाहर में भी एक हम अभी आपको लैब सेफ्टी का भी दिखा देंगे. और इस तरह से आप लोग अभी मेजर करेंगे. एक दो इन्होंने रीडिंग लेंगे. उसके बाद कल हम किसको करेंगे? हाँ, दी पी कैलकुलेशन एंड दी PK ऑफ बेंजोइक. थैंक यू वेरी मच. आप वो लैब सेफ्टी का भी थोड़ा दिखा दीजिए एक बार. आप लोग काम करिए, आप मेजर करिए. अब बंद कर दीजिए. थैंक यू. आई एम वेरी हैप्पी दैट यू हैव परफॉर्म द एक्सपेरिमेंट. And now I got your result. On the basis of your results, I have calculated the cell constant. Now I am worrying about the use of triple distilled water. As I told my first lecture, that whenever you perform any conductometric experiment, the observed conductance of that triple distilled water or double distilled water must be less than 1 microsiemens. But no problem, your observed conductance is, I think, almost around 3 microsiemens. Anyway, so our first part is the calculation of cell constant. You must write the temperature also, because you know whenever we calculate the dissociation constant or cell constant or observed conductance, specific conductance, we must mention the room temperature. Anyway, so you have prepared two solutions. That is, I think, KCl solution. First you have prepared 0.01 molar KCl solution and 0.02 KCl solution, n by 100, n by, you can write like that, m by 100, m by 50. Now your result is like that, observed conductance, and for m by 100 you are getting 0.0031 or 3.1. I have seen your practical record, that is, I think, 3.1 microsiemens, millisiemens. And for second solution, you are getting 1.37 millisecond. So, and these two values, specific conductance, I have taken from the literature, whatever book you are using, maybe Alexander Findlay Physical Chemistry or any data book, CRC data book. So now we are having two values. One is your experimental value, the observed conductance, and another I have taken from the literature, specific conductance. So cell constant formula is like that: specific conductance divided by the observed conductance. So in first case, I am getting 0.892. For the second case, I am getting 1.029, and the mean value is 0.96. Okay, it is okay, no problem. Ideal values is 1. Maybe you know that meter 1 or centimeter. Now my suggestion is that in future experiment, when the other student will perform experiment, they can another solution in order to confirm this thing. I think they can also prepare 0.1 molar KCl again. So they will get 3 values. It will be much better. So, but it is all right. Now I am coming your second part. That means you have measured the observed conductance of 5 different acetic acid solution. Let me see your results. And date of experiment is, I think, 282025. So now the second experiment. Now observation table I have already given you the blank data sheet. So this is observation table number 2. So you have prepared this 5 solution: 1 normal, 0.1, 0.0, 0.001. And with the help of simple conductivity bridge, you measured the observed conductance. You have seen in my practical class there are 2 conductometer bridge. One is available in my research lab, another is in your practical lab. We have used the conductometry bridge of my research lab. So you are getting similar values. In first case, now because acetic acid is molarity and normality, molecular weight and equivalent weight are same, so there is no problem. You can write 1 mole, 0.1 mole, maybe there is no problem. So first case I am getting around 1.7 millisiemens. Then for another solution is 0.53. I think it must be 70. There may be some problem. Then I think we must check these values. It must be 17. Then 0.17. Then 52. This is microsiemens, and this is 13 point microsiemens. So there is a decrease in the values. Similarly, we measure the observed conductance and it is multiplied with the cell constant, which is 0.96. So slight change you see here. So it is 0.508. I have to check this value. Then 0.1632. Then 49.92 microsiemens. This is 12.96, and again there is a decrease in the observed conductance. Then from specific conductance we calculate the equivalent conductance, which is very simple. That means specific conductance multiplied by 1000 divided by the concentration. So in first case I am getting 1.632 Siemens meter square per equivalent, because here you see. Then for second case it is 5.08, then 16.32, then 49.92, then approximately 129.96. Now it is very important data that but this is rubber. What is which one is rubber? Eraser. इसमें no, I think okay. So why it is important? Because when you study in your theory classes the effect of dilution on the conductance, and there is specific reason for that. In observed conductance, when I dilute the solution, the conductance decreases. Here is also conductance decreases. But when I consider the equivalent conductance, there is a increasing. Gradually increasing. Here is decrease. It is decrease. So it is increase. As concentration it is increase. Then we calculate the degree of dissociation, that is called sometimes called the alpha, which is equivalent conductance at particular dilution, equivalent conductance at infinite dilution. So equivalent conductance we have calculated from the experiment, but that equivalent conductance at infinite dilution, that can be calculated from the literature value. You see the bottom, that because acetic acid composed of ionic conductance of hydrogen ion, ionic conductance of the hydrogen ion, and ionic conductance of the acetate ion. So it is also depends on you which book you referred, but I have seen some of the standard textbook. I have seen that the value of hydrogen ion is 349.6 approximately, and acetate ion is 40.9. So if I sum it, so our value is 390.5. So alpha is equal to ionic conductance. You can check it with your simple calculator. 1.632 divided by 390.5. So in first case 0.0041, then 0.013, 0.041, 0.12. So the degree of dissociation, that means the extent of dissociation when you dilute the solution, and you, as you know the Arnia's theory or the Ostwald dilution law, that there is a percentage of the dissociation is increases. So trend is all right. I thought that no, it is also right, no problem. So observed conductance decrease, this is decrease, and equivalent conductance increase, degree of dissociation increase. Now the last part is the calculation of the dissociation constant. So you all know the formula, alpha square C 1 minus alpha is equal to K. These are Ostwald dilution law. As I told you, my first theoretical part, that there is a relationship between K, and if you solve this, so we will get the K values. And if K values is constant, then we thought that yes, our result is correct. I am very happy that when I have calculated, so first case is 1.68 into 10 to the power minus 5. Second case is 1.71. You can also calculate the standard deviation, other thing. It is 1.82. It is slightly higher, 1.87 is 1.64. When I have taken the average, 1, 2, 3, 4, 5 values divided by 5, so I am getting 1.74 into 10 to the power minus 5. Room temperature may be 27 degrees centigrade. And it is very close to your standard values, which is in some books it is like 1.75 into 10 to the power minus 5. In some books it is 1.8. It depends upon the temperature, the observed conductance of the triple distilled water. But I am very happy that you have performed the experiment very carefully. Of course, I am very happy because my research scholars, they have actually very carefully prepared all those solutions, and we have taken 2 conductivity bridge in order to get the correct values. So now the last part is that we have to verify this Ostwald dilution law graphically. Again, there are many techniques or many systems, and you are all aware of the role of strong electrolyte and weak electrolyte. If you plot a graph between the equivalent conductance and concentration for the strong electrolytes, the behavior will be different. If you take the weak electrolyte, the behavior will be different. And in place of equivalent conductance, you can take the molar conductance also. So now in our case I am taking 1, 2, 3, 4, 5. But for good graphs, we need more points, 7 or 8 points. So what I have done, I have taken some values from literature. And that literature I must mention, that is an introduction to electrochemistry. It's a very, very old book, but very good book regarding the electrochemistry. And fortunately, in the first chapter or second chapter, they have given the values of equivalent conductance of various solutions like 0.1, 0.2, 0.02, 0.05, 0.001. And another things, this handbook is available in our library. Whenever you want to see any standard data, I request you to refer this that is called the CRC handbook. You will get the exact value. So from CRC handbook, I have seen the exact value is 1.7 into 10 to the power minus 5. And of course, now sometimes in examination or in practical, they can ask you the calculation of pK of acetic acid. So we all know that pK is equal to minus log of base 10 of K. So if you know the value of, that means bar 5, and if I take the logarithm of 17 or 1.7, so we'll get the value is 4.76. So I'm very happy that your results is very close to the literature value. Now the last part is the graphical representation, graphical verification of Ostwald dilution law, and you can refer many other books. I have also referred many books and other things just for a knowledge, because I have used only 5 values, but I have taken some values for graph plotting. So you see that this is the nature of weak electrolyte. It's a very correct nature is there. And for strong electrolytes, the behavior will be different. And that Ostwald dilution law may not be valid, because if I take a strong electrolyte, HCl or sodium hydroxide or any type of the dissociation, that is entirely different. Or sometimes what you can do, you can plot a graph 1 by equivalent conductance or equivalent conductance 1 by C. So there are so many methods. Another method is that, the crude method, that if I want to get a straight line, so what I do, as I already told you, because our system is K, you have seen, alpha square C. I have already discussed in your, so I can write like that, alpha square is equal to, because K by C. So sometimes what I can write like that, alpha is equal to under root of K and C. So there are so many things, that degree of dissociation is inversely proportional to the square root of the concentration. Don't worry for that, because it is a weak electrolyte, so 1 minus alpha may be neglected. So in order to convert it into an alpha, you know that it is equal to lambda V by lambda infinite. So if I just reciprocal this plot, in order to get a straight line, don't worry about the slope and intercept, don't worry for that. And even we can solve up to this part also. Maybe this slide may be different. I am not getting very 100% straight line, because there is a large gap between this. So you can take plot this part also. Let us see what types of curve is obtained. 0.12, 0.0001 like that. Because this part is, so my students have prepared this graph. So I request you that you just take this part separately in inset. So maybe there may be some straight line. Maybe I do not know exact things, because here some overlapping is there. So 1 by equivalent conductance and C. So there is a straight line. So this indicates the, yes, the Ostwald dilution law is valid, and more important is that you are getting very good constant values. For 5 solutions you are getting almost same values. So now lastly, I must thank Dr. Bhuneshwari Sahu, who is the teacher in charge of the physical chemistry, and my student Sri Abhishek Katendra, research scholars. He has prepared all the solutions. He has taken full pains to perform the experiment very carefully. And of course, M.Sc. first semester chemistry student, particularly physical chemistry. And I think I had given this experiment to 6 students. I have forgotten their name. I think Chesta Sahu or Chandrakar, Chesta Sahu. They have actually performed this experiment. So thank you very much. In my next experimental session, I will discuss about the another important experiment, that is called the pK of benzoic acid or para-nitrobenzoic acid by pH metric titration. So my next lecture will be pK of benzoic acid. It's a very important experiment, or para-nitrobenzoic acid by pH meter. We will use Henderson equation, Henderson-Hasselbalch equation. Thank you very much.